Okay, let's talk about something kind of weird. Why do some things just get hot and other things get cold, seemingly out of nowhere? Well, we're going to pull back the curtain on the hidden chemistry that makes it all happen. You've probably used one of these, right? A self-heating hand warmer on a chilly day, or maybe an instant cold pack for a sprain. And you've probably had that moment of, wait, how does this actually work? It feels like magic, but I promise you, it's not. It's just some really, really cool chemistry. So, at the heart of this whole thing, you've got two totally opposite effects, but they're both caused by chemical reactions. You've got one that gives off heat, and another one that sucks it in, making things feel cold. Let's dive in and see how they tick. All right, first up, the heat. We're going to look at reactions called exothermic. It's a fancy sounding word, but all it really means is that they release energy. The key thing to remember with exothermic is that exo kind of sounds like exit, right? Energy is exiting the system. But why? Well, it all comes down to chemical bonds. Think of it like this. It takes some energy to break old bonds apart, but you get a payout of energy when new, stronger bonds form. In an exothermic reaction, the energy payout is huge. It's way more than what you put in. And all that extra energy, it floods out into the surroundings as heat. It's like a tiny little furnace just kicked on. And this isn't just some weird thing that only happens in a science lab. It's happening all around us, all the time. I mean, the most obvious one is fire, right? Combustion. But it's also what's happening inside those hand warmers. It's even what happens when you mix laundry detergent with water. Yep, that gets warm. And get this, it's the exact same process that is powering your body at this very second. Here's a cool little twist, though. Energy doesn't always have to be heat. Take a glow stick, for example. When you snap it, you're starting an exothermic reaction. But instead of getting hot, it releases its extra energy as light. It's the same idea, just, a different kind of glow. Okay, so we've got the hot side of things down. Let's flip the coin over. If exothermic reactions release energy, what do you think the opposite, endothermic reactions do? You guessed it, they do the complete opposite. An endothermic reaction pulls energy in from its surroundings. Remember our energy payout analogy? Well, for these reactions, it costs more energy to break the old bonds than you get back from forming the new ones. So the reaction has a problem. It needs more energy to keep going. Where does it get it? It steals it. It literally sucks heat energy from whatever is around it, including your hand. That's why it feels so cold. It's like a tiny chemical vacuum, just hoovering up all the heat. And yeah, just like their hot-headed cousins, these cold reactions are all over the place. They are the secret sauce in those instant cold packs. You can even feel it yourself if you mix something like citric acid and baking soda. But the biggest example of all? Photosynthesis. That's right. Plants use an endothermic reaction to absorb energy from the sun to make their food. Pretty amazing. So let's just put it all together, side by side. It really just boils down to which way the energy is flowing. Exothermic, energy flows out and it feels hot. Endothermic, energy flows in and it feels cold. That's it. That's the whole game. And it explains everything from your hand warmer to that instant cold pack. Okay, so this all sounds good in theory, right? But how do we actually prove it's happening? Let's take a peek at how you can measure these temperature changes for yourself in a super simple way. Honestly, the process is way simpler than you might think. All you really need to do is grab an insulated container, like a basic polystyrene cup, just to keep the outside air from messing with your results. Then, you just take the starting temperature, mix your chemicals together, and watch the thermometer. That's it. You're just looking to see if the temperature shoots up or plummets down. And really, this is the golden rule. It's the easiest test in the book. If the temperature goes up, you know energy is being released. That's your exothermic reaction. And if the temperature goes down, you know energy is being sucked in. That's endothermic. Simple as that. Now, if you want to get really good, accurate results, there are a few pro tips. That insulated cup is super important, and hey, putting a lid on it is even better because it traps the energy in, or keeps unwanted heat out. And like with any good science, you want to do it more than once just to be sure your results are solid. Oh, and if you get one really weird result that doesn't match the others, that's called an outlier, and it's okay to just ignore that one. Okay, we've covered the basics, but now for the coolest part. Let's bring all this chemistry home and talk about you. So think about this for a second. The most fundamental chemical reaction for all life on Earth, the one that's happening inside your cells right now, turning your last meal into the energy that's keeping you alive, is it exothermic or is it endothermic? Is it releasing energy
Or is it absorbing it?
The answer is exothermic, absolutely. Every single second, your body is running a gigantic, nonstop exothermic reaction just to generate all the energy you need to function.
And that right there is the big takeaway. That steady warmth of your body, it's not a coincidence. It's the literal side effect of the chemical reaction that is keeping you alive. So, from a little hand warmer you crack open on a cold day, all the way to the engine running inside your own cells, it all comes down to the same thing, a simple story of energy moving in or moving out.